Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is maximum intersecting lines, which is a medium level problem. So before starting today's problem, I would like to discuss something very important with you. So yesterday what happened was I made the video in the morning, and by the evening I believe Geeks for Geeks changed the problem statement very slightly, right? So there was some change in the problem statement, and like the way we implemented the checker function should have been changed. So I got a few comments saying that the code was not working, and I believe that this is not the correct way to watch these videos. These videos are just to guide you in the right direction, to help you with the idea, to help you with the thought process. And if you are having some problem in the implementation part, then these videos are for that particular help. But after watching the whole video, if you are not able to correct like a small change which was made in the problem statement, then it means you're not watching the video properly, or you're just here for the code. So I believe that this is not the correct way to watch this video, and I highly recommend you, if you're watching these videos, to just like go through the whole video. If you're not even getting a single idea of the problem, just go through the whole video, understand the problem, and then try to code it on your own. And again, if you're having some problems in the implementation, then you can again check the coding part, and then you can clear your doubts related to the implementation. After you have cleared all your doubts, you should be able to code the whole question on your own, and in the future, if there are any changes in the problem statement, you will be able to manage them on your own, right? So I highly recommend you to watch the videos properly and understand the concept. So this is very important. Now let us quickly start with today's problem statement. It says that we have been given in horizontal segments that are arranged on the x-axis, right? So like we will be given the starter and the end point of each segment, and we have to find the maximum number of intersections possible of any vertical line with at any point, right? So this particular question, like to simplify this, the last line, it says that we have to find the point of maximum intersection. So like we have discussed a technique which is used to calculate the same thing, and it's like where we have range updates and a single point query, especially when we just have to add or subtract numbers. It is very useful. It's a DP technique, and I've already discussed it in previous problem of the day videos. So I don't remember the date, but it was, the question was update queries, and like we discussed that particular technique in that video. But this problem is a slightly different from that technique, and the reason is the constraints. So like to perform that DP technique, all the points must lie in the range like around 10 to the power 5, which is the size of an array. But since here the constraints are like from minus 10 to the power 9 to 10 to the power 9, that technique will not be useful. And by will not be useful, I mean that we cannot implement it the same way, but the base idea that we had there will be the exact same, and we are going to implement that particular thing in a different way. So let me just like copy this particular test case and explain how does this problem statement work. So I have this test case, and it says that we have some points. So let me just draw a number line first. So let's say this is a number line, and this is point 0, this is point 1, this is point 2, point 3, point 4, and 5. Let's say we have it like this, right? So the first segment is from 1 to 3. Now it means that the first segment is like this. This is my first segment, right? The second segment is from 2 to 3. So the second segment is like this, right? The third segment is from 1 to 2. So the third segment is like this, right? Now if I try to find the intersections, you would see that at this particular point there are two lines that are overlapping each other. So here there are two intersections. Again, if I like try to find at this particular point, or if I try to find at integer points, then again two intersections. But at index 2, you would see there are three lines that are intersecting, right? So the first line is this one, the second line is this one, and the third line is this one, right? So there are three intersections here. So how do we find like the number of intersections at any given point, right? This is our task, to find the maximum number of intersections. So the key idea is the number of intersections, like the number of intersections, let us denote it by dp of I. Although we are not going to use dp, I am just saying that if dp of I denotes the number of intersection at point I, then it will be equals to all the lines that have started before until the correct index will contribute to this answer, right? So for example, if I am talking about index 3, all the lines that have started at index 1, index 2 as well as index 3 will contribute to its answer, right? So I'll have start of 0 plus start of 1 plus start of 2 plus start of 3. So start of 1, start of 2, start of 3 is denoting the number of lines that have initialized or have their left end at index 1, that are starting from index 1, that are starting from index 2, right? So these will be contributing, these are the possible contributors which will contribute at index 3. Now among these lines, all the lines that have ended at index 0, that have ended at index 1, that have ended at index 2 will not contribute to the final answer. So initially we just assume that all the lines that are starting before the index 3, including the index 3, will contribute to my answer, right? But among those lines, there will be some lines that ended before even reaching the index 3, right? And those will be end of 0, end of 1 and end of 2, right? End of 0, 1, 2 denotes the line that have ended at that particular index, right? So I have to remove these values from my answer. This is my idea. Now, how do I do this when the values are very large, right? So the values are like up to minus 10 to the power 9 and up to 10 to the power 9, right? So how do I do this? There is a very interesting thing that you will notice about this question is that the best answer, so it can be any value, right? But you would always observe that the best answer will always be one of the starting points, right? So if some lines are starting at index 0 or index 1 or index 2, the answer can be 0, 1, 2. And if some lines are starting at index 4, right, so the answer can be 0, 1, 2, 4. 3 is also a possible answer, but the best answer will always be among the starting indexes, right? If we just take the starting indexes, we will not miss anything. Now let me just explain you how this works. So if there is no line starting at index 2, at index 3, right? So if there is no line starting at index 3, that means let us say that some line started at index 0. So one line started at index 0 like this. Some line started at index 1 like this, and some line started at index 2 like this, right? But I know for sure that even if all the lines are continuing, the answer will not increase at index 3, it will still be the same at index 2, right? So there are two possibilities, right? The first possibility is some lines get terminated at index 2 and our answer will get reduced. But that is for sure. But if that is not the case, one thing is for sure, that even if no lines get terminated, the answer for index 3 will never be greater than the answer for index 2. Why? Because there are no new lines at index 3, right? So there is one thing for sure, that the answer, if I just take the start values, I'm never going to miss the best answer, right? The best answer might exist at some other indexes as well, but if I just take the starting values, I'm never going to miss my best answer, right? So this is my first intuition. Now how do I calculate this value? So essentially, what is dp of I? dp of I, so now I am just considered about the starting values I, the indexes at which at least one line is starting, right? So now I am only considered about those i's. So for those i's, I'll have to like make the summation of all values where I is from 0 till the current I. So let us take n. N is from 0 till current I, and I have to do start of n, right? Similarly, I'll have to subtract all the values where n is from 0 till less than I or I minus 1, and I'm just doing end of n, right? Now I have to calculate this value effectively, right? How do I do this? So an easy way to do this is, let us store all the values of starting and ending points in a map, right? Since the map is already sorted, what I can do is I can calculate the prefix sums of the ending vector, right? Since the values in the map are already sorted, I can create like a prefix sum kind of thing for the ending vector. Now I just do the same thing with the starting vector. Instead, when I am calculating the prefix sum at each index, listen carefully what I do. At each index, for example, if I am at I have calculated the prefix sums. That means I have calculated this part for the starting array, right? So there are some values which I want to remove now. So what I do is I initialize the to remove. That means these are the values I want to remove. So I just do, like, I just mark it at 0. Now since these values are sorted, I can do a binary search on it, right? And I can do binary search on maps using an inbuilt function. So I'll be using ent dot lower bound, right? So what I pass to it, I just pass the current index I, right? So now this particular function is going to return me a pointer either to the index I or some value greater than I. In both the cases, I am not interested in this value. I am interested in the last value that is smaller than this particular value, that is smaller than I. So it might be I minus 1, it might be I minus 2, it might be I minus 3, right? So for example, let us like assume that we got the value I minus 3. Since we have already computed the prefix sums in the end vector as well, that means the value at index I minus 3 will store the sum of all values from 0 till I minus 3, right? So I'll get the value of to remove. What is the value I want to remove from it? So I'll just do the current value of prefix of summation of starting points minus the to remove value. So this will be the number of intersections at my current index. And I can just check whether it is greater than my best answer. Then I'll update my best answer. Otherwise, I'll leave it as it is. Right. So this was the solution for today's problem of the day. Let me just quickly summarize what we have discussed and now. So the problem statement says that we have to find the maximum number of intersections given the starting and the ending point of some segments. Right. So we are not going to use dp, but I just write it. I have just written it as dp of I. So dp of I denotes what are the number of intersections at index I, right? So for example, in this case, I have assumed I equals to 3, right? In case of I equals to 3, the answer will be all the points that have started at index 0, started at index 1, started at index 2, started at index 3, like these are the possible contributors to my answer. Now all the lines that have ended at 0, ended at 1 and ended at 2, that means that have ended before even reaching my current point, they are going to be removed from my answer because they're not going to contribute, right? So this is the value of dp of I. Now we discussed about what can be the possible answers. We discussed that any point, if we take all the points which have at least one line starting from it, then we will be able to form our best answer. And I have discussed it how, if we like just ignore this point 3, we are still going to get our answer, because the answer for 3 is never going to be greater than the answer for 2, right? It can be smaller than or equal to, but it is never going to be greater than. So it is just safe to take all the points which have at least one starting point, right? So what I do is I just create two maps, start and end, and I just stored the frequency of all the lines which are starting from the start point I. Since the map are already sorted, what I can do is I can create the prefix sums for both of the maps, right? So first of all, I create a prefix sum for end map, and then I start creating the prefix sum for start map. Now while creating the prefix sum for start map, what I do is, for example, if I'm at index I just do binary search on the end map, right? And since it is always prefix sum, if I do lower bound, it is going to give me a value greater than or equal to I. Since I don't want the value I need a value smaller than I just move one step backward. For the pointer, I can do minus pointer, right? So I'll get a value that is smaller than the value I, and I can take all the values. Since it is always prefix sum, I'll get all the summations from 0 to that particular value. So I can just subtract it from my current value of start of I, right? So this is how I'm going to create the answer for the index I, and I can just update my best answer. So let me just show you the code for this problem now. So here's a map with a start and end. Now I just traverse to the input vector lines and I just increment the frequency of all the items, right? So there is a line at starting at item of 0, so I'm just incrementing, and there is a line ending at item of 1, so I'm incrementing it. Now I want to like update the add maps as prefix sums, right? So I just traverse through the end map and I increment the second part or the value of the current item as end sum, right? I just add it to my end sum. Now since the second part will have the summation of all values till the ith index, what I'll do is I'll just set end sum as year of second, right? So this way I'll be able to update all the values. I do the same thing, exact same thing in the start map, but instead while doing this I just do one more thing, and that is I just create a variable called remove. So these are the values that I have to remove from the current value, and I just do binary search using lower bound on the end map, and I'm searching for e dot first. So this is the index that I'm looking for. Since I'm not interested in any value equals greater than or equal to e dot first, I need to do the pointer minus minus, right? So if the pointer is not equal to the end or begin pointer, so if it is not the first pointer, then I can just safely like decrement the value of the pointer and set the value of remove as the second part of this particular pointer, right? So I'm going to get the prefix sums from this particular value. Now once I get this, I can set my answer as max of answer comma e dot second, that is the current value or in the start map, minus remove, that is the value that I have to remove, and at the end I can just return my answer. So this would be the solution for today's problem of the day, maximum intersecting lines, and I hope you guys were able to understand the solution. So like if you guys did, then you can consider dropping a like on this video, and don't forget to subscribe to this channel. It's always free of cost, and you can always unsubscribe later if you don't find the content interesting. So don't forget to share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.